Hello guys, welcome to my channel, and today we are starting with the data science. So first library to start with is the Numpy. So let's head back to the Jupyter notebook and let's begin. Okay, so what is a Numpy? So there are some basic libraries in Python like Numpy, pandas, then matplotlib, which is used for visualization, etc. Okay, so what is Numpy here? So Numpy stands for numerical Python. It is a Python scientific module which is created to perform a typical numerical calculations on multi-dimensional arrays along with some other sophisticated functions. Okay, so it also provides ease working with linear algebra and carrying out complex calculations like matrix inversion, Fourier transforms, etc. Okay, so Numpy is widely used in data science. So let's study like one by one its functions. Okay, so let's begin with like the basics. So for example, if you have a list here, okay, so you have created list here, so let's make it like homogeneous list. Okay, then what you can do is you can print the list plus 5. If you try to add 5 to the list, it will throw an error. Okay, so because this is list, right? So list have some limitations, so that is why it is throwing an error. Okay, now if I print the type of list 1 here, so it is int here. Okay, but if I print the type of list now, then it will print string. Okay, so the type varies here. Okay, so these are the two things you need to remember when it comes to the list. Okay, but in case of Python, right, so let's copy this list here. Okay, and let's make it homogeneous. Okay, now if I want to like import the library of NumPy, then you need to import it as import NumPy as np. So as stands for the naming convention, like whatever you want to give the short form to it. Okay, you can give anything here as your name or any other your super character. Okay, but usually we follow this convention, import NumPy as np, and for other libraries it is import pandas as pd, and for matplotlib.pyplot as plt. Okay, so in similar way you can follow this rules. Okay, so in case of NumPy, we are importing the library here, and after that we are giving a list here. Now this list is converted to a NumPy array. Okay, so np dot array converts this list to an np numerical Python array. Okay, now if I try to add 5 to it, then it will definitely add. Okay, and if I try to print here, so you will get the list like the NumPy array, whatever you are printing. Okay, so this is how it works. So 6 7 7 8 9. Okay, so 1 plus 5 is 6, then 7 7 8 and 9. Okay, so this is how it works in case of NumPy array. And if I get the type of list here, so if I get the type of list here, it is NumPy int 32. Okay, and also you can find out the size of the list here. Now in case of a.n bytes, you can give like you can print the size here, so it is 24. So if you are declaring a list like np.array, and you are creating a list here like NumPy array, and then you are specifying a data type, you can also specify data type. Okay, and then you can find out the type here. Type of a is numpy.nd array. Okay, so this is how you get the data type. You can also give here np.float. Okay, float 16 or 32 or 64, anything is fine. Okay, and the data range changes as you give here. Okay, so next is the matrix creation. Okay, so there is one function called as reshape or method. So it converts whatever an NumPy array you are giving into whatever size you give, that is row and column. So 2 rows and 2 columns of matrix we need, so it is converting it to 2 rows and 2 columns. Suppose if I give 3 here, then it will throw an error because those many elements are not present, that is 2 3s are 6, so you need to have 6 elements here. Okay, 5 and 6, so then it will create. Okay, so this is the work of reshape in NumPy array. Okay, you can also directly create the matrix like np.matrix 1 2 and 2 3. Okay, so this also works. If you want to add one more here, it also works. But if you add the rows and columns in different formats, that is 1 2 and 3, then it will throw an error because you need to always match the rows and columns. Okay, that means if you are declaring a matrix of 2 rows in the initial phase, then you need to have it, okay, in that way itself. Okay, that means if you are having 1 row and 3 columns, then you need to follow that convention itself, 1 row and 3 columns in every stage, okay, for 2D array. Okay, so now if I am declaring this to q, and if I want to get the dimension of the array, then q dot n dim will give you the dimension. Okay, so using n dim you can find the dimensions. Okay, so there are other functions or methods here in case of numpy library, that is np.i. so basically if you press shift tab, you will get the what the function does here. Okay, so for example, returns a 2D array with ones on the diagonal and zeros elsewhere. Okay, so here np.i, n is like how many elements you want, that is 3, and m is none. You can also specify this, and k is from where you want to start the elements here. Okay, for example, I have given k as index position 1, so it is starting from 1. If I give here 0, then it will start from 0. Okay, so that is the number of elements. So it is 3 cross 4. If I give 4 cross 4, then it will create 4 cross 4, like that. Okay, so np.i creates the identity matrix. Okay, identity matrix. Okay, then np.zeros is creates a 0 matrix of the size whatever you provide. So 3 cross 3 is this, and if I give just the single, then it will create only 1 row. Okay, so 3 comma 4 is like this. So this is the use of np.zeros. Now next is np.ones. so it will create the number of ones how much you want. Okay, in the similar case like this zeros, and also you can specify the data type here. Okay, so 3 cross 3 is this, then 3 comma 4 is this. You want to single, then you can get just this. Okay, so this is the function of np.ones. Okay, now if you want to convert the entire array into some other data type, you can follow either this convention, or you can follow use as type. Okay, so if I remove this and np.array of array 1, okay, and if I x this, and if I take this here and uncomment this, it will print still the same. Okay, that means we are converting this to complex data type. Okay, and if I want to convert it to float, then it will create to float. Okay, sorry, so this will create to float. Okay, let's comment out this. This will create in full. Okay, so whatever data type you want, you can specify either this way, or you can specify either this way, np dot and the data type. Okay, now you can also form the matrix using like this, np.ones 2 comma 4. so 2 comma 4 is 2 rows and 4, and if you want to multiply it with something, then it will return like that. Okay, so 1 is nothing but ones, all are the ones, that is 1 1 1 1 1 1, that. So you are multiplying it with 2. If you want to multiply it with 3, then you will get all the 3s. Okay, so this is the use of ones here. Okay, now there is one more function, that is sum, which gives the sum of matrices. Okay, for example, we are declaring a 2 mat here. Okay, with the name matrix, and if I give here, so it will give axis 0. so whatever sum we are getting, it will get like this. Okay, it is 3 plus 3 is 6, then 3 plus 3 is 6, 3 plus 3 plus 6, and 3 plus 3 is 6. Okay, if I give axis 1 here, it will give like this, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, like that. So it will sum like this in case of axis 1, and in case of axis 0, it will sum like this vertically, and in case of axis 1, it sums up horizontally. Okay, so you can also get the mean here of the same. So as you can see, the mean is 3 here in case of 0, and in case of 1, it is 3 comma 3, that is column wise. Okay, so you can try to practice these, because it will get confusing a bit. Okay, so now h stack like stacks the array in matrix into horizontal, and v stacks vertically. Okay, so let's comment out this. So you can get like this h stack, so it flattens the array 1 2 3, then 2 3 4, and in case of v stack, it prints like this 1 2 3 2 3 4. Okay, now using a range, you can also reshape, like a range used to create an array of whatever range you want. For example, a is equal to np dot a range 6, and you can dot reshape it to 2 comma 3. Okay, so if I try to print a, so it will give like this, so 0 1 2 3 4 5. So these are the elements in the a range. Okay, So we are creating three matrices here. Then what we are doing here is we are using linear algebra here. So linear algebra multiple dot, that means we are multiplying everything. Okay, so it will give the multiplication of all the three matrices here. Okay, so and also it will give a determinant also using algebra. Okay, so np dot linear algebra dot det gives the determinant of the matrices whatever you are giving. Okay, so next is linspace. So linspace creates evenly spaced numbers, like how many you want from the range. Okay, for example, you are giving 1 to 8 but you want 3, so it will divide 1 to 8 into 3 equal parts and it will give you this. So if I want to get 4, then it will give like this. Okay, so this is the use of linspace here. Okay, so these are some things you can try it out. Okay, so this was all about like the basics of numpy. Okay, so let's go to my GitHub and try to understand something else. Like, have I missed something? Okay, numpy basics. Okay, so numpy is the library to scientific compute. Okay, it provides high performance multi-dimensional array object. Okay, so we are importing a library like this, then you are creating a library. Okay, so the format of R. Okay, so then we can get the shape, then length of array, then dimension, then data type and type. Okay, so these are the things you can have a look upon them. So np dot zeros will create the zeros like this, then data type. Okay, it's the same. Use of a range is to create the range, that is start, stop and step, whatever step, or the evenly spaced parameters. Okay, linspace creates the same. Oh sorry, in case of a range this is the step, in case of linspace it is the evenly spaced. Okay, then there is one more thing, use of full. For example, you are creating a matrix 1, you want only one matrix of 2 comma 2. Okay, and what is should be the element, it should be 3. Okay, so that is how it is printing. So 3 comma 3, so that is 2 cross 2, but the elements are 3 comma 3 3. Okay, and you are printing two matrices in which the element which is of size 3 cross 4 and the element is a. So this is the use of full. Okay, so I is nothing but the identity matrix. So in case of indexing and slicing, we have seen it earlier, so you can have a look upon it. Okay, so 2D array. Okay, you can do all the arithmetic operations here using np.array, but in case of list it had limitations. Okay, so next is arithmetic functions. So array.sum gives the sum, then mean you can get, the variance also you can get, then standard deviation you can get, then min max, that. Okay, so you can also find out the range using max minus min. Okay, then you can also do the transpose using np.transpose of a matrix. Okay, so you can also concatenate using np.concatenate of two matrices. Okay, so stacking is h stack and v stack. Okay, np, okay, h stack and v stack. So column stack, there is also one more thing, that is column stack. So last three. So this is stacking by column, it will stack like this, and in case of d stack it also stacks like this, but in case of flattening it works as a horizontal stack, that is h stack. 1 2 3 4 5, last 1 2 3 4 5. Yeah, so in case of horizontal stacking and flattening works same. Okay, so this is how it works for nd array dot flatten. And then what we have left, yeah, so this is all about the numpy. Hope you understood something. So in the next class we'll study about the pandas. Okay, so if you learned something, then hit that subscribe button. Till then, stay tuned, stay connected, take care, bye bye.